about functions and their domain and range. So before we start, we should, of course, talk about the definition of domain and range so we can use this freely. So domain, I want you to always think of domain as your x-axis. This is how much I can go if I'm on a graph from left to right. So here's my x-axis. Domain is right here on your x-axis. So if I have a graph, let's just do a line to start with something simple. Actually, I want to change the color. So same line, but I want to put the color. Alright, here, this arrow means that this line is going to go on forever and ever and ever. So my domain is going to be going to every single negative number. And it never is going to stop because this line never stops. So since it's not going to stop, this is going to be negative infinity. But we can't have this equal to negative infinity. So when it's not equal to something, we're going to put parentheses. So that means that these parentheses mean that it's open, so I'm not going to ever have it able to be equal to something. Now, when I'm going all the way to the right, we got to find out where this line stops. This line never stops, so this is going to be infinity. And we just found out that the domain of this line is negative infinity to infinity, or your book usually will say all real numbers. And this fancy R right here, all that means, this thing, all that means is real numbers. And if this domain is talking about the x-axis, that means our range is talking about, yep, you guessed it, the y-axis. So here is the y-axis, and the range on this graph, you're just trying to find when does this not get a value. So I'm going to pick any x, and this line goes on forever, so no matter what, if I go over, I'm going to hit this line. If I go over, then I'm going to hit the line if it kept on going right here. So I'm going to be able to pick any positive y and get an answer. Likewise, I'm going to pick any negative y, and if I went over to the left, I would hit this line. So all you're checking is to see which number will I be able to pick, and I won't be able to run into that line or function that I'm looking at. So since I'm able to hit this all the time, no matter which y I pick, this is going to be also all real numbers. And if I were to do interval notation, I could also say my real numbers are from negative infinity to positive infinity. So let's skip this. So when finding the domain of a function, we have to find a way to break the machine. Is one way you can think of it. So my machine that I'm talking about is this function right here. So this is my machine. So if I put a number in here, I need to get something out that doesn't work for us. Well, fractions are easy. How do I break a machine when it has a fraction? Well, I'm just going to want to make it to where this f of x is going to be 1 over 0. Because we know that this, whenever you have a number, I could even have 3 over 0. I could pick anything on the top, but if I'm dividing by 0, this is undefined. So it breaks the machine. So here, when it's undefined, if it doesn't make sense why it's undefined, think about fractions. So this is saying I have 3 slices of pizza out of 0 slices. How does that make sense? So that is why it's undefined. So which number will break this machine? Well, when x is equal to 0, this won't work. So in interval notation, this is where it might get hard, is that I'm going to want to say that I can I pick any negative numbers? Yeah. So I can pick from negative infinity to what number? Well, 0. Can it be equal to 0? No. So if it were equal to 0, Don't put this in your notes yet. I'm going to show you what it would look like if it were equal to 0. This would be like that, a bracket. But since we're not making it equal to 0, we're going to put parentheses. But let's put it in green as well, so it looks nice. So now, negative infinity is 0, and I'm going to want to say that this is or. I can pick or on here from, can I pick anything for the positive? So can I pick any variable x for the positive? Well, yeah, I could pick any positive number and this will still work. So the machine only breaks when it's at 0. Now I'm going to change this or. I'm taking it kind of slow because this is our first introduction to interval notation. So this is negative infinity. Well, that doesn't really show up on that blue. Let me change the color. So this is now is negative infinity to 0. And instead of the or, we're going to put union. That symbol right there means or. Union. Or 0 to infinity. So this would be your answer for this one for interval notation. Here we have f of x is equal to 1 over x minus 2, right? So same thing, I want to find out when does this not work. Well, here we just set it equal to 0, right? Because we want to find when this is equal to 0. Well, that makes sense. There's no work to be done. When x is 0, then this bottom becomes 0. So what number needs to be here to make this whole thing 0? So you set x minus 2 equal to 0. Do the inverse operation, and x is equal to 2. So now that x is equal to 2, and I get this as 0, that means that 2 breaks this machine. It's not going to work because when I plug it in, if you don't see it yet, plug it in your paper and see it. And you'll see that you get 1 over 0. 2 minus 2, 0. So now we have that this is going to be, so now we're going to want to put it into interval notation. So can I pick any negative number besides this? Yeah, the only time it broke, the only time I got 0 was x equals 2. So I can do the same thing here. It's going to be from negative infinity. I can pick, this is saying I can pick any negative number for that x, and it'll still work. It won't break the machine. So where do I have to stop? Well, I have to stop at positive 2. Is that equal to it or not? It's not equal, so I'm going to be putting the parentheses. Brackets means equal. And I'm going to pick or, so I want to do union. 2, where I left off here, has to repeat right there, to any positive number I can pick as well. And if you don't believe these positive, negative, test a couple points. Pick any positive number and see if you break the machine. And you'll see that you can't because the only time you get 0 is when x is 2. So that's why we're solving for this equation right here. This tells me when the machine breaks. So when does this machine break? When I have a square root. So solve this for me. Don't look at the function yet. What's the square root of negative 4? Well, if you've gotten to this part in algebra, it's going to be square root of 4. I squared. Square root of 4 is 2. Square root of I squared is I. So we're now into the imaginary numbers, which is not a good thing. We don't want to do that, because if we had imaginary numbers, then my graph would have to change to where this is now x, and this is my imaginary. And so we're not even in a real number graph. We want this to be y, not imaginary. So let me erase this so I have some room to work. So when does it break? So looking at this example, it's when this has a negative number. So we have to find a way to set this up to where the inside has to be greater than what? Well, if you think about when it's negative, or when it's positive, this is going to be 3x plus 2, right? And we're comparing this to 0. So this number has to be either greater than or less than 0. Well, I want this number to always be positive. So I'm going to say that this has to be greater than or equal to 0. So when does it work? So this is going to be subtract 2, 3x is greater than or equal to negative 2. We now have, I'm going to move it over here, 3x is greater than or equal to negative 2. I just rewrote it. Divide by 3, inverse operation, and it's a positive 3, so we do not have to flip this. So as long as x is greater than or equal to negative 2 over 3, then we'll be okay. If it's less than that, we won't, because we're going to pick a higher negative number. So let's test that. So if the next number, whole number up from here, it would be negative 1. So if I put negative 1, let's see, if I say x is equal to negative 1, so the way I'm testing this, because that might not be clear, here's negative 2 over 3, right? On the number line, it fits right here, negative 2 over 3. So when this number is greater, that's when it breaks. That's when it does not work. So here, I have to pick something over here, and I'm going to test to see if that's true. So if I put negative 1 right there, then I'm going to want to say that this is 3 times negative 1 plus 2. You get negative 3 plus 2, which is negative 1. I make this all square roots. Can you do the square root of negative 1? No, because it's negative, right? So my domain here, this is kind of getting out of hand. Let's kind of clear this area a little bit. So I'm going to group this up. Okay. So the way I want to write my notation then is as long as this is from negative 2 over 3 to infinity, we're okay. So is this going to be equal to or opposite? So let's test this. So if I plug this back in, this is 3 times negative 2 over 3 plus 2, right? This becomes negative 2 plus 2. I get 0. So it can be equal to this, right? So I can say that as long as this is equal to negative 2 over 3 and 2 positive infinity, then I'm going to be okay. So in other words, look at the number line. This is saying from here to all the way to positive infinity. Okay, that's how we're doing our notation. So analyze what the graph may look like for the functions above. We can skip that. Okay, so let's work on these problems. We're trying to find the domain of each of the following functions in interval notation. So we might not work on every single problem. We'll see how it goes. So let me get a marker. All right. So we're dealing with a fraction. When you see this fraction, if you look back at the notes, then you'll see that when we have this fraction and there's a variable on the bottom, you're always going to want to set this equal to 0. Set equal to 0. So this means that I'm going to want to find 13 minus x is equal to 0. I'm setting this part equal to 0. And the reason why we're doing all that, 13 minus x equals 0, sorry. So the reason why we're doing all that is because we want to be able to see when we get 1 over 0. because this 1 over 0, remember, means undefined. So if I were to minus 13 both sides, inverse operation since this is a positive, then this becomes negative x equals negative 13 multiplied by negative 1 both sides. This becomes x is equal to positive 13. So that means 13 is when I get 1 over 0. That's when this is going to break down the machine. So now that I have that, I need to write it in my interval notation. Well, answer this question. Can I pick any x that is negative and not break the machine? So you'd say yes, you can. So I can pick any negative. And if you didn't see it right away, actually pick some negatives, plug it in, and see if you can break the machine. So negative infinity to what? Where does the machine break? Well, it tells me it breaks at 13. So I'm going to put a 13 right there. And, oh, let's see this. So is it going to be equal to or not? Well, when it's equal to 13, right? It's equal to 13 right here. This breaks the machine. Breaks machine. Okay. Over here, when what we're writing right here are the solutions when it does not break the machine is what I'm writing over here. So I don't want to say equal. Equal would mean this. I don't want that. So I want to put parentheses as well because it's not equal to 13. Now I know when I'm talking about the other side, I'm going to duplicate that 13. Put a comma. Now can I pick any positive number? So check, pick some actual positive numbers, and you'll see that it's actually infinity. So now this is my union. And if you're wondering why I'm picking union and not intersection like this, is look at a Venn diagram. If you're talking about union, then you're talking about the area over here and the area over here. Okay? Here we don't, in this problem, to make it look better, these circles aren't even going to be intersecting. This is my union, is that I have to pick this one or this one. They actually don't share anything. So I can't pick this because the lines stop right there. So if this is my domain, and 13 is right here, and these are my negative infinity and positive infinity, this 13 right here breaks it up. So I have to pick union. I pick intersection when they actually do share something. And I'm only looking at those solutions where they both work for that. Here I'm picking this one or this one. So this one would be intersection. So if you need to copy that down, pause the video. I'm going to erase it in a second. Okay, g of x is a radical sign. So is the radical sign and 9 plus x. Okay? So we have this radical 9 plus x. And remember from the notes we were saying that the radical, we want to make it to where it's not going to give you a negative number. So we have 9 plus x, and we want this to be greater than or equal to 0. Right? So here we're going to say that this is going to be subtract 9, and this will give you x is greater than or equal to negative 9. So now we have to figure out if I'm going to have this. So as long as it's x is greater than or equal to negative 9, then it'll work. The times when it doesn't work is when this is less than 0. So if this one was less than 0, this wouldn't work. But we're trying to, here it's a little bit different than up here because we're trying to go straight to being able to put it in notation. Because now I know my options. If you put it on a number line, it helps a lot. So if I put negative 9 here, 0, and then I'll put just another 9 here to represent my positive numbers. So that means that I'm going to put negative 9 and I'm going to be able to go all the way here, and that's my domain. I can pick any of these. So I can pick this -9 because it'll just give me 0. So for interval notation, this would be brackets, and then here's an infinity right here, so parentheses. So just like this, if you wrote it out like this and then got that far, you would be able to very easily transfer this. So I already did my brackets, I put a bracket. I see that's -9, I put the -9. Put a comma, and now I'm on to any positive number, so I'm going to put infinity. And my parentheses, because it cannot be equal to infinity. And I'll leave the other two problems to for you to do, because this one is D. You're going to follow the same way as B because of the radical sign, and A, you're going to follow the same way. Let me make these. So A and C are similar. Any other questions, email me back.